Hi everyone, welcome to another very quick introduction video, this time on V2X or Vehicle to Everything. We have seen some vendors even call the X part in the V2X as anything, so they call it Vehicle to Anything, but since 3GPP calls it Vehicle to Everything, we are going to stick with that. This video builds on another video that we recently made on connected and autonomous vehicles. So these are collectively, the connected and autonomous vehicles are collectively known as CAVs. And if you're not very familiar with the topic, then I would advise you to check the video out. This is the summary of what we mean by connected and autonomous vehicles. We wouldn't be going through all of them here, but as you can see, they will be useful for many different things like infotainment, emergency calling, roadside warnings, telematics, and remote warnings, navigation, etc. So let us very quickly recap the concept of unicast and broadcast here. Unicast is one-to-one communication. When your device communicates with the network, it is generally always one-to-one or point-to-point communication. So this is known as unicast. In case of broadcast, a single node transmits information that can be received by all receivers that is listening. So this is also known as the point-to-multipoint communication. A simple example is the way we receive terrestrial TV or radio. So we wanted to ensure you that you understand the concept because in case of V2X, all nodes broadcast information that can be received by all other nodes. While in case of terrestrial TV and radio broadcast, the broadcast is always one way from the transmitter to the receiver. In case of V2X, we will see that all nodes can broadcast and all nodes can receive broadcast information from other nodes. So coming back to V2X concept, let us discuss the basics here first to understand what do we mean by everything in the V2X. The first is V2V or vehicle to vehicle. In this case, all vehicles broadcast information that can be received by other vehicles to find out the location of the other vehicle or the speed, velocity, direction of travel, etc. The other vehicles can also use this information to avoid any accidents. Then we have the vehicle to infrastructure or V2I. Infrastructure is a broad term that we have discussed in another of our video. Here the vehicle communicates with the infrastructure that can make intelligent decisions. So a traffic light can decide the optimal signaling, for example, or a special type of infrastructure called the roadside unit or RSU can amplify the signals from vehicles to send them even further. Then the vehicle to network or V2N communication includes connectivity that can be used for all kind of things like we discussed in the connected car. Vehicle to pedestrian and pedestrian to network comes really handy, for example when vehicles are driving in difficult situations like if there is fog or heavy rain, or even in scenarios when it is difficult to see a cyclist or people crossing the road. So together these form part of what we describe as cooperative intelligent transport systems or CITS. Now some publications just use the term ITS instead of CITS, but they are slightly different. While intelligent transport systems or ITS focuses on digital technologies providing intelligence placed at the roadside or in the vehicles, CITS focuses on communication between those systems, whether it is vehicle communicating with another vehicle or with infrastructure or with other CITS systems. Also, don't confuse the C part in CITS with cellular, please. There are two different streams of V2X standards. The first is based on IEEE 802.11 standards and more specifically the IEEE 802.11p standards, which is derived from the 802.11a standards. I'm not an expert in 802.11 standards, so I have provided a couple of reference in the slides that you can actually learn more about this technology. I'm sure you are aware that all our slides can be downloaded from our SlideShare channel. So look for the link at the end or in the description of the video. So these IEEE 802.11p based standards have different names, different spectrum and slightly different implementation in different parts of the world. In the USA, it's called Dedicated Short Range Communication or DSRC. In Europe, it's called the ITS G5. Sometimes people even shorten it to G5, which can be confused with 5G. Finally, Japan has its own ARIB STD T109 standard. There is an evolution of the 802.11p expected to be available in 2021, and it will be called the IEEE 802.11bd. It's supposed to overcome some of the limitations of the 802.11p. The other stream is the cellular V2X or the C V2X as we generally call it. Many publications omit the C part in the C V2X and that can sometimes be confusing. So we prefer the C V2X when talking about the cellular V2X. You can see the evolution of C V2X here. We will explain it in a bit more detail later on rather than here. Now you can find some of the references that show comparison of 802.11p versus the CV2X. We are not going to look at them here. The spectrum allocation for the Cooperative Intelligent Transport Systems or the CITS in various countries as shown in the table here. Due to the standardization of V2X in 802.11p preceding the CV2X standardization in 3GPP, spectrum allocation was originally intended for the 802.11p based system. However, the regulations and technology are technology neutral, so you can do a deployment of CV2X in exactly the same band. 3GPP has introduced the LTE band 47 for V2X, which is positioned as the UNII-3 5 GHz unlicensed band. So the cellular V2X may require the use of unlicensed bands to solve regulatory issues related to LTE Direct, where devices broadcast directly to nearby devices, right? So if it's in a licensed band, then there could be all sort of problems. So you have to have an unlicensed band. V2X will operate in a way like the LTE-LAA, or where LAA stands for the license assisted access. So you will have carrier aggregation with the operator's license band, especially for communicating with the network. We are going to look at device to device or D2D communications in a minute. But just before we go there, I want to be sure no one gets confused between the machine to machine and device to device. When we talk about machine to machine or M2M, it's also called machine type communications, MTC. We are talking about some kind of a sensor or a thing that is involved, right? When we talk about a device, it can have a lot more sensors, maybe a user interface, and a lot more. So a smartphone shown here is an example of a device, but a connected car can be considered a device too. When we talk about LTE, device to device in LTE standards is called side link, or sometimes just SL for side link. And the new radio interface is called PC5. There are two high-level deployment configurations currently defined in the specifications as shown here. Time synchronization is achieved in both cases based on GNSS or the Global navigation satellite system. Most people call this GPS, but GPS is just the American standard, right? There are other GNSS systems like GLONASS, which is a Russian system. In European Union, we have Galileo, and China's system is called Beidou. So configuration 1 is based on distributed scheduling. It is also known as mode 4 or transmission mode 4 or TM4. Think of this as a scenario where there is no network coverage or network is not involved in the V2V communications. If the device is in RRC idle state, for example, it would make sense, it would make more sense, right, for distributed scheduling, as there is no need to use resources from the E node B. Here the vehicles have to synchronize, decide on scheduling, and manage interference so as to be able to communicate and not cause any accidents. So scheduling and interference management of V2V traffic is supported based on distributed algorithms implemented between the vehicles, and this distributed algorithm is based on sensing with semi-persistent transmission. This is because V2V traffic from a device is mostly periodic in nature. Additionally, a new mechanism where resource allocation is dependent on geographical information or zones is introduced. Such mechanism counters near-far effect arising due to in-band emissions. Finally, the V2X spectrum, that is the band 47, is used for communication over PC5. Configuration 2 is based on E-node B scheduling. It is also known as Mode 3 or Transmission Mode 3 or TM3. In this case, the device is in RRC connected state. So in this case, the device is in coverage of the network and in the RRC connected state. UE sends E-node B a scheduling request. Scheduling and interference management of V2V traffic is assisted by E-node Bs via control signaling over the UU interface. The E-node B will assign the resources being used for V2V signaling in a dynamic manner. Licensed spectrum is used for communication with the E-node B, while unlicensed V2X spectrum is used between the vehicles. So here is a list of RRC system information blocks that contain side link information. So actually I should mention the LT RRC system information blocks, right? So that contains side link information, and this is just to make you aware. So this is from the 36.331. As you can see, the presence of SIB 18 and 19 indicates that the network supports side link, right? SIB 18 contains side link communication related resource configuration information, and SIB 19 contains the side link discovery related resource configuration information. SIP 21 and 26 contains the V2X side link communication configuration, and this finally SIP 28 contains 5G NR side link communication configuration. So 3GPP-TR 38.885 describes various side link operation scenarios that are being studied as part of the 5G NR V2X. They map very nicely to the 5G network architecture options we discussed in an earlier video. Scenario 1 is the same as option 2. Okay, so this is the 5G network architecture option, in which G-Node P provides the control configuration for a UE's V2X communication via the LT side link and the new radio side link. Scenario 2 is the same as option 5, right, in which a next generation E-Node B provides control configuration for the UE's V2X communication in both the LT side link and NR side link. Scenario 3 is the same as option 1, so LT network today with no 5G. So as we just saw, SIP 21 and 26 contains V2X side link communication configuration, and the SIP 28 contains the 5G NR side link communication configuration. Okay, so jumping directly to scenario 6, which is the same as option 3, the non-standalone or ENDC, right? So the same SIPs we saw earlier, 21, 26, and 28 is used for the communication configurations. So without going into details, scenario 4 is the same as the 5G network architecture option 7, and scenario 5 is the same as option 4. So a very quick look at the basic non-roaming architecture for LTE-V2X from 3GPP-TS 23.285. I have colored all the UEs or devices red. So as you can see, UEA has LTE-UU link as well as PC5 link to UEB and UED. UEB does not have an LTE-UU link, only the PC5 links with UEA and the vehicle, which is a vehicle, and UEC, which is a pedestrian. So finally, the UED is stationary, so something like an RSU or infrastructure. It will always have an LTE-UU link and will have PC5 links based on any of the vehicles in proximity. This is the non-roaming 5G architecture for V2X communications and is exactly the same as in LTE case, except that this is in a 5G system. So you can look at this offline in the slides. Finally, I wanted to look at platooning use case with 5G. So platooning enables the vehicles to dynamically form a group traveling together. If all the vehicles start and finish at the same location, then only the lead vehicle will generally have a driver. There is an option that vehicles can join and leave midway, in which case all the vehicles will need a driver. Vehicles in the platoon receive periodic data from leading vehicle in order to carry on platoon operations. The lead vehicle takes control of the speed and direction of all vehicles in the platoon. When the lead vehicle brakes, the following vehicles automatically brake with zero reaction time, significantly increasing the road safety. So the advantage of this feature is safer driving, collision avoidance, and improved traffic efficiency. It also improves fuel efficiency, reduces accident rate, and enhances productivity by allowing the drivers of the following vehicles to perform other tasks. Frankly, I think they might just be watching videos or they might be just on TikTok. So there are several aspects of platooning that may be supported through reliable V2V communications, such as joining and leaving a platoon. That is, to allow the vehicle to signal its intention to join or to leave a platoon at any time while the platoon is active, and to support additional signaling in order to complete join leave operations, announcements, or warning to indicate formation and existence of a platoon so that nearby vehicles can select to join or to avoid disruptions to the platoon. Steady state operation group communications to support the exchange of platoon management messages and even further to indicate braking, acceleration, road selection, change of platoon leader, etc. So frankly, there are still outstanding challenges that has to be solved for this feature to become common. So all you would really see is some kind of a demo or trial, right? Or an implementation that works on a very quiet road or in some closed area. But for it to become common to be seen on the roads, there are, I think, frankly, still a lot of challenges that need to be solved. So some references for further reading. Now, if V2X is an active area of research for you, then we suggest that you watch the Qualcomm webinar that also has a lot of technical details. Okay, here is the technical specifications related to V2X. You can actually go to the V2X section on the 3G 4G page and you can find the same specifications with the links, so you can click on the links and directly navigate to the 3GPP site. Okay, quite a few 3GPP technical reports related to V2X. Right. So hopefully you like this short video on introduction to V2X. We tried to keep it to a very high level but also provide some necessary details. We intend to do a technical deep dive into this feature sometime in the future. So in the meantime, stay safe and do let us know if you found this helpful. Comments and suggestions are welcome. Thank you and goodbye.